Singapore's decarbonisation push is exposing digital infrastructure gaps in the power system as utilities try to run a more complex, low-carbon grid while keeping power reliable and affordable. Joining us today to discuss this are Professor Lawrence Loh from the NUS Business School and Joshua New from Wood Mackenzie. Gentlemen, thank you very much for joining us today. Joshua, what are the biggest digital infrastructure gaps currently hindering Singapore's decarbonisation efforts?
As we look at the future of the energy system that we have, it becomes increasingly distributed. We have variable renewables coming in. We have got a demand side that is increasingly flexible as well. And so the grid really needs to be able to cope with all these different changes, and there is a huge investment that's required there. And this has been highlighted by kind of EMA's future grid capabilities roadmap that really highlights the importance of the grid. Also, we are looking at companies, and I think companies here are starting to look at how they can effectively introduce more automation, more digitalization into their processes, making them more efficient so that they can compete as well.
The systems themselves, many of these may be fragmented or even legacy, meaning that it's been around for a long time without innovation. So we need to actually pump up some of these systems to the latest. And then there's also the issue of data. Right now, there's limited real-time data in this energy grid. I think it's good to plug this gap as well. And of course, many of the platforms, in some way, sometimes they are quite isolated. So we need to actually connect them better to make them interoperable. And last but not least, of course, is the issue of cybersecurity, because this is something quite critical so that the system can continue to withstand many cyber attacks and even hacks and even certain mischievous behavior from some other parties.
Why are companies allocating higher capex toward energy transition initiatives?
One of the key things that drive this high capex is obviously the current emphasis in the world or even in specific countries to decarbonize, to lower their carbon emission in line with the requirement of global agreements. And secondly, the another driver is this energy security in itself. We need to continue to invest so that we can assure continued uninterrupted supply. And of course, regulation play a part. Many countries, including Singapore, is making sure that many of our high emitters of carbon continue to be sustainable in terms of their operations.
You know, you can look at it from a cost perspective, right? By increasing efficiency, by increasing productivity, they effectively reduce their cost. At the same time, investing in energy transition really allows them to reduce their carbon risk. You know, Singapore has a carbon tax in place, and that carbon tax will only increase. And of course, you do have the CBAM, the Carbon Border Adjustment mechanism in Europe coming into play as well. And last but not least, it's really about being able to participate in the green economy. So, you know, companies do see value, both strategic and financial value in investing energy transition. And just as a point of reference, from Wood Mackenzie's analysis, you know, we see the need from between 130 trillion to up to $170 trillion required for investments to enable the energy transition globally.
What key capabilities must smart grids have to effectively integrate higher levels of renewables?
It's really about automated controls, right? So historically, it's been easy, I would have to say, or I would say easier, because you do have a few large generators, so gas-fired power plant here in Singapore, but increasingly you are seeing rooftop solar coming into play, you know, behind the meter battery storage coming into play as well, and you have power import. So the balancing needs of the grid increases, it becomes increasingly complex, and automation is fundamentally required to ensure that, you know, the grid remains stable and balanced. And last but not least, I would have to say it's really about the two-flow, the abilities for power to flow two ways in this grid. But going forward, you know, with distributed energy resources with rooftop solar, with battery storage, increasingly you are seeing demand kind of end users becoming also suppliers into the grid. And so that two-way ability of the grid to actually manage flows in two ways is really, really important. The one last thing I would have to say, which often doesn't necessarily come up, especially from an energy supply perspective, is really around cybersecurity and data integrity. And as we go forward, in digitalizing our systems, not only from a grid, but just from a demand perspective as well, that will become a huge part of focus as well.
So being smart, they will allow this high technology capabilities to actually make them more efficient. They can actually also perhaps help to predict load forecasts better. And of course, smart grids are very important. And of course, this will depend on the interoperability capability of many of the disparate systems. And I think some of the capabilities will be the ability to do real-time monitoring, as well as responding to changing demand. And last but not least, again, is the issue of cybersecurity. This is maybe the bottom line, the most important capability, so that energy can be available and it will not be amenable to attacks from some other parties, even in the whole world.
Well, thank you both for joining us today. Thank you for sharing your insights, Lawrence and Joshua. Once again, our guests were Professor Lawrence Loh, Director, the Center of Governance and Sustainability at the NUS Business School, and Joshua New, Vice Chairman and Head of Asia Pacific at Wood Mackenzie. For more news, please visit asian-power.com.